Um, Welcome to the game seminar and the MediaX-sponsored game seminar. Thank you guys for coming today. We have Holly Pope presenting today. She's going to be talking about digital math games and mathematical thinking and digital game-based learning, and in particular about a pilot study with a math game app called Wuzzit Trouble for elementary school students. Holly is a doctoral candidate here at Stanford in curriculum studies and teacher education, focusing on math education. She's got 18 years of teaching experience, so she knows what she's talking about, from pre-kindergarten through 6th grade, including 5 years as a math instructional coach in a K-8 urban charter school.
As you just heard, I was a mathematics teacher, instructional coach for 5 years before I came here, and part of that part of my professional goal was to bring quality mathematics to elementary school children. And so now as a researcher, while I'm working on my PhD, I still have that goal in mind, but I'm looking at it from a different angle. And today I'm looking at it through the lens of a digital math game. So I'm going to tell you a story about math learning, gameplay, and what identity has to do with all of this. And so, as you know, if you log on to Google Play or the App Store, you'll see that there are thousands and thousands and thousands and thousands of digital math games out there. However, not all of them are the same. Most of them privilege just procedural mathematics and memorization of basic facts. This is a screenshot of one particular game that has beautiful colors. I love the colors. Purple's my favorite color. But the focus is on the subtraction algorithm. And also, you notice that, you may not be able to notice, but in order to actually get to the gameplay, you have to earn coins so that you could go here and actually play the game. So the mathematics is sort of a separate add-on to the game mechanics. On the contrary, or to contrast that, we have Wuzzit Trouble. How many of you have heard of the game Wuzzit Trouble? Okay, it was developed by a company called Brainquake. Keith Devlin, who's the head of H-Star, co-founded that company. And he had this dream of making a math game that was more than just building procedural fluency. And so if you take a look at the game, you see in the center of this mechanism, you have this cute little creature called a Wuzzit. And in order to solve the puzzle, you have to move these smaller gears so that the larger gear will line the key up with the pointer. And so the one great thing that I love about this game is that there's multiple paths to the solution. The game, not only does it build procedural fluency, but it also builds problem solving and mathematical thinking. And it gives the math a context. And more importantly, the math is embedded into the game mechanics, unlike the first game that I showed you. And so before I go on, I want to give you a chance to play Wuzzit Trouble. A lot of people have a hard time understanding the game unless they experience it a little bit. So if you have an iPad or an iPhone or any kind of mobile device, you feel free to go to one of the app stores and download it. I won't be offended if you're looking at your phone and playing. I would prefer that you do that so that you could sort of understand the learning that's happening in the game. If you choose not to download it, that's fine. I'm going to go through one of the puzzles as we talk, just in case you decide not to download it. And I also want to give you an outline of my talk today. So we are about to engage in gameplay, and then I'm going to show you a game evaluation framework that I came up with as a result of interacting and studying Wuzzit Trouble. I'm going to share some research and findings, some surprising results that haven't been published about this research yet. And we're going to explore some experiences with Wuzzit Trouble, look at implications, future research, and I'll open it up for questions. And so now I'm going to take you through one level of gameplay in Wuzzit Trouble. So when you open the app, you get to this page, and you press play to get to this one. And so there are 3 rooms, what they call rooms in the game. This is the first room, which is the botany lab. There's the invention room, which you can see part of it over here. And then there's, you can't see it at all, there's the future tech room. And so you click on the botany lab, and then you see that there are 25 puzzles in this particular room. So you click on one. If you've never played it before, you would click on the first one. And it gives you an information page of how to solve the puzzle. So the whole purpose of solving the puzzle is getting the key. If you get the key, and no matter how many moves it takes, you will get a star. You will solve the puzzle, great. However, if you want to be more competitive, you can try to get the key in the least amount of moves as possible. And if you do, you can earn more stars. And so this is what the first puzzle looks like. So what you have to do is you have to turn the smaller gear that has a certain amount of cogs on it. Has a 5, so it has 5 cogs. And you need to turn this either to the left or to the right so that the larger wheel will move and line the key up with the pointer. And so how many turns of the smaller wheel could you make to line up the key with the 10? I could tell, so first of all, I could tell who the teachers are because they're in the back, hello, raising their hands, and they're answering the question, so thank you. They held up 2 fingers, so, and which direction would you turn it? Would you turn it to the left or the right? I just showed you. So you would turn it to the right 2 times. And so the larger wheel will move to the 5, and then to the 10, and then magic happens, and the Wuzzit is released, and very happy, and yay. And because I solved this in the least amount of moves possible, I earned 3 stars. So my first time playing this level, I think I earned 1 or 2 stars, but the great thing about Wuzzit Trouble is you can go back and replay that level, and that's very important when you're working with elementary school children who are developing their mathematical thinking. And so I've walked you through a level of gameplay, and now I'm going to talk about this game evaluation framework that I've been using to think about digital games. And so Wuzzit Trouble caused me to think about 2 things that made it such a great game. And one is the math dimensionality, and the other is the engagement and game features. And I'm going to explain what both of those mean. The math dimensionality is the complexity of the mathematics. You have one-dimensional mathematics, and then you have multi-dimensional mathematics. One-dimensional mathematics is characterized as memorization, focused on procedures, no connections to the concepts, and sometimes even focused on speed, and the answer is valued. To contrast that, we have, or maybe this looks familiar to you. If you're close to my age or older, you may have had 100 problems like this that you had to do over and over again and really had no idea, no true understanding that you were doing multiplication. So this is an example of a one-dimensional task. And so a multi-dimensional task is different. It has procedures that are connected to the concepts. It allows the player or the student to grapple with mathematics. The problem-solving process is valued along with getting the right answer. And there are many solution paths. And in some cases, representations and connections to patterns and relationships are valued. And here is an example of a multi-dimensional math task. A farmer's pen has a high fence around it. He can see 32 legs under the fence. How many sheep and ducks are in this pen? How do you know? And so in order to solve this task, the student or a person needs to think differently in a much different way than the student would have to think in the previous task that I showed you. And so there's the multidimensional mathematics, and then there's the game engagement and features. And so this, for me, includes the visual aesthetics, the rewards and point earning structures, the level of challenge. Is the math incorporated into the game mechanics, which, as I said before, is extremely important. And so Wuzzit Trouble is high on the math dimensionality and also high on the engagement and game features. You could also have some games that are high on the math dimensionality, which I have seen some, but low on the game engagement features. Or you could have games, most of the games are, some games are low on the game engagement and low on the dimensionality. And I've found some games that are low on math dimensionality, but high on the game engagement. And so I've been using this to think about math games in my work. So now I'd like to share with you some research about that I used with two third grade classes, and the findings from that. And I set out to determine if there was a significant increase in the math learning of students who played Wuzzit Trouble compared to students who did not play Wuzzit Trouble. And so my study design, I had a comparison group who did not play the game and a treatment group who did play the game. The comparison group took a pre-assessment, had math instruction as usual, and then they took a post-assessment. The treatment group had taken the same pre-assessment on the same day. Then they had math instruction as usual, except there were 10 minutes set aside for gameplay, and this happened 3 times a week. And then they took the post-assessment over a 4-week period. I told you about the pre-assessment and post-assessment were crucial in this study because that was my measure. And so I want to show you some of the problems that were on this assessment. There were 2 types of problems. One type was the multiples problem, and these problems were based on the mathematics that were directly related to the math in Wuzzit Trouble. These are also problems that students may have seen in their curriculum materials or maybe even on a standardized test. So students could have been familiar with these. And then there was this problem. And I'm going to give you a minute to look at it because this is a problem that is multidimensional and it takes us a minute to think about that. I don't know if you can read it, so maybe I'll read it to you. You have a set of digits from 0 to 9. Arrange these digits in the boxes below to make 2-digit numbers as close to the targets as possible. You may use each digit only once. Tell the order in which you completed the items by marking them A, B, or C. And so the students had to create a 2-digit number that was the largest odd, given the digits here, the largest even, given the digits that were left over that they didn't use here, and a number close to 50 but not including 50 with whatever digits were left over. And it's very important for the students to tell us the order that they did it because depending on where you start, your answers are going to be very different, but it'll still be correct. Does that make sense? And so that was the digits problem, and this problem made a big difference in the results, as you'll see. And so my participants were 2 third-grade classes. They had the same teacher. They were in a very selective school that's somewhere in the Bay Area. It's a public school, and so, but they had to take a placement test in order to be able to attend this academy. So these students had very similar achievement levels. And what the teacher called the lowest class played the game. And so like I said before, these children had to have high ability levels in order to get into this school. And so the teacher separated the kids into the classes according to whether they knew their multiplication facts or not, which is something that, some schools do that, some don't. But the teacher did that. I did not do that as a result for the study. And so here are the results. So the red line is the comparison group, and the orange line is the treatment group. The pre-assessment was significantly different for the groups. So even though both of them scored fairly high on the assessment, the comparison group scored significantly higher than the treatment group on the pre-assessment. But at the end of gameplay, when they took the post-assessment, the post-assessments for the two groups were statistically insignificant. There was no significant difference. So the treatment group basically caught up with the comparison group as a result of gameplay. You can look at the bar graph, and this shows the mean difference between the pre and the post-assessments for each group. The mean difference for the comparison group was not significant, but the mean difference for the treatment group was significant. And so we were very excited about these results, and we decided to look a little deeper to see where the difference was coming from. And so I separated the total score by the type of problem, and most of the variations seem to come from the digits problem that I showed you earlier. And so the comparison group, there was no change between the pre and the post on that particular problem. But for the treatment group, the change on that particular problem was significantly higher. And so we were extremely excited about these results. And knowing that the digits problem seemed to make the difference in the total score, I wanted to look at which students were able to meet each of the constraints of this problem. So remember, they had to make the largest number, they had to know what odd is, they had to know what even is, they had to make a number close to 50, they had to use all the digits only once, and they had to make 2-digit numbers. So there were 6 constraints. And so what I did was I counted how many students were able to meet each of the 6 constraints on the pre-assessment, and then how many students were able to meet each constraint on the post-assessment. And so this represents the percent change in the number of students who were able to meet each constraint. And so here's 0, this dark line is 0, and anything to the left means that there were less students on the post-test than the pre-test who were able to meet those constraints. And anything on the right means that there were more students who were able to meet the constraint on the post-test. And so you can see that students in the treatment group were more students were able to use digits once, use a 2-digit number, and make the largest number. There was not much difference between making even and odd number, and that was partly because in 3rd grade, by the time students are in 3rd grade, they understand what even and odd is, and so 99% of the students were able to do that. So I wasn't expecting to see much change here. This number, this one close to 50, the comparison group lost a significant amount of students who were able to meet that constraint on the post-test. The treatment group lost a few students as well, but the difference was not significant. And so looking at these results, I'm excited, I'm thinking, I'm like happy, and I'm like, I need to figure out what it is about this particular problem that is picking up whatever the learning is in Wuzzit Trouble. And I thought about 2 things. One is that in order both to solve Wuzzit Trouble and the digits problem, the students have to think about several constraints at the same time. And so Wuzzit Trouble, you're restricted by the multiple on the gears, you have to reach a certain number, and the more you play, you'll see that you can only turn the small gear up to 5 times. It won't let you turn any more than that. And similarly, for the digits problem, as I told you before, there were 6 constraints that they had to attend to all at the same time in order to solve that. Also, they had to engage in a complicated decision-making process for both Wuzzit Trouble and for the digits problem. And so to solve both of them, you have to try something out, check it to see if it works, and then revise your answer in case it doesn't. And then you have to just ask yourself all of these questions about what to do next. So that was extremely exciting, awesome results. And now I want to take you to something surprising that I found that I didn't expect to find after looking at these results. So I wanted to dig more into what was going on with the treatment group. And so I decided to separate the score, look at the scores by race and gender. And I'll give you a second to look at that. And so you can see on the pre-assessment, you have your non-white males here, your non-white females here, and your white males here and white females there. But on the post-assessment, by the end of gameplay, the white students improved drastically. The non-white girls barely improved, and the non-white males improved a little. And so, as a researcher, these results are not significant. My treatment group was too small. It was only 29 students. I wasn't expecting anything significant. But as a teacher, if I was a teacher with a classroom of 30 kids, I would look at this and I would freak out because some of my students are learning and some of them are not. So that is a problem. Now, one thing that is troubling that I don't know is I did not watch the kids as they played the game, so I don't know how they interacted with the game, and I don't know what their math environment was like because I wasn't there. And so basically, that's gonna be my next step that I'll talk to you about in a bit. So I decided to go back to the literature, and there's James G. He's very popular in the game world, and he has these 36 principles of good game design that foster learning, and his last 3 principles focus on culture. And he says that good games should allow the player to think consciously and reflectively about the world, about themselves as learners, and about their environment without diminishing their own identities, abilities, or social affiliations. So it's like, okay, good, some game designers are thinking about this, that's good to hear. Or hopefully. And then I also went to the math literature and I looked at, there's a lot of literature in mathematics about identity and impact of identity, of instruction on identity. And when I say identity, I mean how one sees themselves and how they are perceived by the world. And we also know, it's very common knowledge, sadly, that there is a perceived achievement gap between whites and Asians and African Americans and Latino students. But we also know that these results are not differences in intellect. We know that these results are differences in the opportunities that students have to learn and to show what they've learned. So there is no inherent differences by race in mathematics. It's not something that's inherent in the individuals. It's something that is going on either in their environment or what is offered to them to learn or to show learning. And we also know that there are math teaching practices that strengthen mathematical learning and cultivate student mathematical identities. So with all of this in mind, it caused me to think differently about the game evaluation framework. So not only did I start thinking about the math dimensionality or the game features, I also started thinking about the potential of a game's theme to impact a student's identity. And so now I want to talk to you about my quest to explore what these experiences with playing Wuzzit Trouble could be. And I just so happened to come across this little girl who needed some help in math. I call her my little research assistant because she needed help in math and I needed to get to the bottom of how students might be experiencing this gameplay. And so we decided to help each other out. This little girl is a European American. She is 9 and she is delightful. She loves problem solving. She is basically the highlight of my week is working with her. And so I introduced her to Wuzzit Trouble, and she was on this, and the first thing she said was, "Oh my goodness, I just love the Wuzzits. They're so cute." And so she played and played and played, and all of a sudden, she stopped thinking about math, and she asked me a question, and she said, "Are they trapped by a mad scientist?" And I said, "Oh, no, I don't know. What makes you think that?" And she says, "Well, look, there's all this smoky fog, and then there's these test tubes." And I said, "Oh, well, I don't know. I'll have to find out about that." And she said, "Well, it's either a mad scientist or an evil witch." I was like, "Oh, yeah, she's pretty perceptive." Kids, I forget how perceptive kids are. They notice things that, for me, I didn't really notice that when I first was playing Wuzzit Trouble. And so she made it to the second level. She was working really hard on this. She liked to go back and retry the levels so she can get more stars. And she was just focused, and I was helping her through it like a teacher would, probing her with questions to push her thinking along. And all of a sudden, she lifts up her left hand to cover up the left side of the screen, and she turns her head and she says, "Oh, I can't wait to get away from that robot." And I said, "What robot?" And she pointed to this robot. How many of you saw that robot over there? I did not see that robot. I played this game hundreds and hundreds of times and never saw that robot. And that robot took her out of her mathematical thinking and distracted her because she thought it was creepy. She said the red eyes are creepy, right? So, I mean, and this is not to say that that Wuzzit Trouble is a bad game for girls. That's not what I'm saying. I'm also not saying that girls should not be playing games that are mechanical or have to deal with robots. That's not what I'm saying. I just want to make that clear. Because some people might essentialize girls in games that way. But this caused me to think about not only about the impact of identity, but even just personal preference. What do people want to see, and how does their personal preference affect the learning from the game? And I started thinking about my own experiences. I presented the math evaluation framework with Anthony in France last year, and part of that was we were my friend Anthony back there, wave Anthony. And part of that was we started to explore some games and evaluating them along the lines of the framework. And I came across this game. So this was my own experience with personal preference in gameplay. And I open up the app, and this is what I see. I can't get to any mathematics until I choose one of those. What's the problem with this? Anybody want to say?
You may not identify with either of those people depicted, i.e. like maybe a different race.
Right, right. I had to choose. Exactly. I do identify as a female, but I do not identify as a white female. I'm a black female. Sorry. And so for me, I had to pick something that didn't really represent me in order to get to the mathematics. And honestly, I didn't even pick anything. I just closed it and said, we're not using that one. And so, and then this game. Now, this game is not a math game, but how many of you know the game Battleship? I played this when I was younger, and it helped me to learn coordinate grids. And as a teacher, a lot of times you pick games that may not have been used for mathematics to learn math. And so this is a digital version of the game. And as a teacher, I would have probably years ago picked this for gameplay to learn coordinate grids. But what if I had a student in my class who came from a war-torn country? Would this game still be appropriate to play? No. You don't want to introduce a kid to this game when they may have seen bombs falling on their village, right? And so these are things that we need to think about, not just the math dimensionality and the engagement in game features and the potential to impact identity, but also even personal preference. And so I'm working on a game evaluation framework 2.0 that might include personal preference, or I might combine the identity impact and personal preference. I don't know yet. I'm gonna depend on my math friends to help me work through that later. And so now I'm gonna talk about implications. So the most important one that I think needs to happen is game designers need to engage with math education experts in the process of designing their games. A lot of times game designers or companies look for math education experts or teachers to endorse their games after it's done. But this is important for them to engage with math ed experts so that they can incorporate the mathematics into the game design, similar to Wuzzit Trouble, to the way Wuzzit Trouble incorporates the math into the game. And also think about the impact of identity and individuality of their potential players. For teachers, definitely need to think about evaluating games along the 3 criteria that I pointed out, and effective ways of incorporating games into instruction. Hopefully my future research will work on that. And for parents, most parents have engaged in mathematics in the same ways that we have when we were young, with that very first example of one-dimensional mathematics. Math to them is just learning procedures and memorizing facts. And so parents will think that one-dimensional games are good for their kids because that's how they learn math. Well, I argue that parents need to rethink what they think about mathematics, and along those lines, learn how to evaluate games along the dimensionality of math, the engagement, and potential for identity impact. And so lastly, I'm going to share quickly about the future research and open it up for questions and comments. So right now, I'm working to collect games that could be used as assessments. So there's this new movement about using digital games as an assessment tool, not just as an intervention. And also, I'm looking and designing written assessments that will pick up the multidimensionality of the game, similar to the digits problem. And so hopefully I'll be able to put these together and run a bunch of different experiments with children and see what they're learning from different kinds of games. Like I said earlier, I did not get to see how the students engaged with the game when they were playing it in the previous study. And so my dissertation is going to focus on how the kids are engaging with the game in their instructional environment. I think there's either something about the game itself that may have contributed to those differences, or something about the math classroom environment in which they were playing the game that could have contributed to those differences. So hopefully I will be able to get to the bottom of that. And so in the distant future, or maybe not so distant, I would like to test different backgrounds of the same game and see if that affects student learning. I think my little research assistant showed me that the backgrounds make a difference and the backstories make a difference. And so I would like to see how that affects outcomes. And most importantly, or very important to me, is developing professional development for teachers about choosing and using games in their classrooms. Oh, and by the way, I forgot to say this, but for Wuzzit Trouble, I spoke to Keith Devlin. He told me that the original backstory to this game had a mad scientist trapping the Wuzzits. But he told me that he specifically did not want that to happen because he didn't want to advance stereotypes about scientists. And so I know that he was thinking about the game design when he designed it, but I don't know how much, and you know, we've been talking about this, I don't know how much he realized that the backstory, that people would make their own story about the backstory and how it might affect how they interact with the game. And that's all. Thank you so much.